Hey guys, so we're going to be looking at the very final topic of Maths A level, really. This is the last one that we've been doing, and it's a recap, but it's also adding in some new things. We're looking at binomial expansion, but we're doing the year 2 version of this. So, in year 1, you found the binomial expansion of a plus b to the power of n, where a and b could be anything. They could be a number, they could have been an expression, like an algebraic expression. But the catch was, this was only when n was a positive integer. So what we do here is in this year 2 version, we extend this so that n can be any rational number. So in other words, that means it can now be negative or it can also be fractional as well. So we can extend these ideas, okay? So first thing that we're going to learn how to do is how to do binomial expansion for negative or fractional powers. And this is where we start off, where this first number that we have here is 1. This is the easy version of it. Then we're going to be looking for the next exercise where the constant that you have at the beginning is not a 1, and we're going to think about how we do that one separately as well. And then the third thing is just doing some partial fractions before you actually end up doing the binomial expansion. So we're going to kick off with a bit of a reminder of what binomial expansion looks like in year 1. So pure 1 recap. Remember that for a small integer n, you could use a row of Pascal's triangle for the binomial coefficients, and then you have descending powers of the first term and ascending powers of the second. If the first term is 1, we can ignore the powers of 1, because obviously 1 to the power of anything is just going to remain as that. So let's just go to, is going to remain as a 1. So I'm just going to do a quick reminder of Pascal's triangle. So we've got our 1, 1, 1, and then 1, 2, 1, 1, 3, 3, 1, and I'm going to need to go up to the next couple of rows for these as well. So 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. If you're not sure how to do this, you're going to need to do some recap from pure 1. So for this first one that we've got here, it's nice and easy. It would be, first of all, 1 to the power of 5, so it's just going to be a 1. Then we've got our next binomial coefficient, which is 5 from this row that we're doing here, and that's going to be 5x, so we're increasing the power of x. Then the next one we would have 10, and we're going to have increasing the power of x again. We're then going to have a 10, and we're going to increase the power of x again. And we're then going to have a 5, and we're going to increase the power of x again. And then we've got our last one, which is just the 1 coefficient, which is our x to the power of 5. So you can see you've got 1, 5, 10, 10, 5, 1, 1, 5, 10, 10, 5, 1. And you can also see that the x is going to power of 0, power of 1, 2, 3, 4, and 5. So this one follows a similar kind of pattern, except this time we're going to be using this row that we have here. So we're going to start off with 1 plus 4 multiplied by this thing that we've got here, which is 2x. And then we're going to have the next number, which is 6, and that's going to be multiplied by 2x squared. Make sure you're squaring the whole thing there. And then we're going to have 4 multiplied by 2x cubed, and then we're going to have, 1, so we've got 2x to the power of 4. So just doing some simplifying here, that's going to be 1 plus 8x. 2 squared is 4, multiply that by 6 is 24, so that's 24x squared. 2 cubed is 8, and 8 times 4 is 32, so that's 32x cubed, and 2 to the power of 4 is 16, so you get 16x to the power of 4. Same thing kind of down here, except we're going to be using this row. So we're just going to have 1 plus minus 3x multiplied by 3, because we've got the 3 coefficient, plus 3 multiplied by minus 3x squared, plus 1 multiplied by minus 3x cubed. So you can see how we've got the coefficients, like we did here, 1, 4, 6, 4, 1, 1, 4, 6, 4, 1. We've got 1, 3, 3, and 1. We don't have to worry about any of these powers for 1, because it's just 1 to the power of anything is just 1. So you end up with 1 minus 9x. Now 3 squared is positive 9, and multiply that by 3 and you get 27. So you get plus 27x squared, and then negative 3 cubed is going to be negative 27x cubed. Okay, so this is just a recap of things that you should have known from pure year 1, sorry. And we're now just going to do a bit of a recap around binomial coefficients and actually how you can find them in a different kind of way. So for the binomial coefficients, if you had this n choose 1, the way that actually this comes up with n choose 1 is just n. And I'm hoping you can remember what it is for n choose 2. For n choose 2, it is n multiplied by n minus 1 divided by 2 factorial, which is just 2, isn't it? Now for n minus 3, it is n minus 1, n minus 2, all divided by 3 factorial. So I'm sure you can now predict what it's going to be for n choose 4. The top is going to be n minus 1, n minus 2, n minus 3. Notice how you've got 1, 2, 3, 4 things. And you're then going to be having here 4 factorial. So you previously knew how to do these. These are the same things as that come from Pascal's triangle, but these formulae also give those same correct values for the binomial coefficients as well. So we can actually do it with integers in place of n. Remember, n is like the power that we have, but you can also do it with negatives and with fractional or sort of decimal terms as well, okay? So for this one that I've got here, if n is 10, and we're doing it to choose 3. So it's going to be like this kind of one that we've got here, apart from it's going to be 10 in this place. So it's just going to be 10 multiplied by 9 multiplied by 8, all divided by 3 factorial. I haven't got my calculator ready. So I'm going to grab my calculator. Remember, 3 factorial is just 3 times 2 times 1. So that's 10 times 9 times 8. Divided by 6. So that coefficient is 120. Now it also works with negatives, okay? So here it's going to have choose 2, so it's going to be using this kind of thing. So it's going to be a minus 1, and you're going to be multiplying it by a minus 1, which is minus 2. So you're taking away 1 each time, and you're going to be dividing that by 2 factorial. Well, here you've got a negative times a negative, so you get a positive, so it's just 2 divided by 2 factorial, so it's just 1. And then here, if you had the power was minus 2, so if n was a minus 2 this time, and you're going to do choosing 3, so you're finding like the third binomial coefficient, so you will do n multiplied by n minus 1 multiplied by n minus 2, all divided by 3 factorial. I'm using this kind of one here, n minus 1, n minus 2 over 3 factorial. So here we've got on the top 2 times 3 times 4 divided by 3 factorial, and clearly the top is going to be a negative, and when you divide that you get 4, so you get negative 4, okay? You can also do it with decimals too. So if n is 0.5 and we're doing choose 2, it's going to be an n minus 1 over 2 factorial. So it's going to be an n multiplied by n minus 1, because 0.5 minus 1 is minus 0.5, all divided by 2 factorial. So it's going to be a negative, clearly. So I've got 0.5 times 0.5 divided by 2 factorial, and you end up with negative 1/8. Okay, so that's what the coefficients would be. So this is how we're actually going to generate these binomial coefficients, but we're going to generate them for negatives and fractional terms. So it's going to be a lot easier when you see this with an example. So this is how we do binomial expansion, okay? We would say when it is 1 plus x to the power of n, you just have 1 plus nx, and that's because the first coefficient is going to be an n, plus n minus 1 over 2 factorial x squared. That's because that's the next coefficient. n minus 1, n minus 2 over 3 factorial x cubed. And that goes all the way to n choose r for x to the power of n. That just depends really on how far you're actually going in this expansion, okay? So really all the pattern is that you need to know is it goes 1, n for the coefficient, n minus 1 over 2 factorial, n minus 1, n minus 2 over 3 factorial, etc. And it just kind of keeps going. So for binomial expansions where n is either negative or fractions, they are infinitely long, because if you think about it, when they are whole numbers, if you keep going across, eventually you get 0. You actually get that it doesn't keep going, it stops at a particular point. But for these ones, they're just going to keep going and going and going, okay? So we're going to start off by doing this one that we have here. We're going to do binomial expansion to find just the first 4 terms of this, and you'll get a sense of why it would keep going forever in just a second. So the first thing I've got is I've got 1 over 1 plus x, and the first thing I need to do is make sure that I can write it in this particular form that I've got here. So it's going to be a 1 plus x to the minus 1. Now, when I have it looking in this form, you can use this that you have here, and by the way, this is in the formula book. So you just get 1 plus n I'm going to write here that n is minus 1. N is always the power. So you get 1 plus n, which is minus 1, x, which is x. So you get 1 minus x, plus n multiplied by n minus 1 over 2 factorial x squared, plus n minus 1, n minus 2 over 3 factorial x cubed. You see how this formula looks really complicated, but after you start doing it, it just builds up. You just look at the previous one, you add on one subtractive from it, and you increase the what do you call that? Factorial term at the bottom. And I'm going to stop there because we only wanted the first 4 terms. So I've got 1, 2, 3, 4. So we're just going to simplify. 1 minus x, and please do write this first line out here. So first of all, think to yourself, is it going to be positive or negative? Well, clearly it's going to be positive here, and so you've just got 2 divided by 2, so it's just going to be 1, so it's plus x squared. And here, is it going to be positive or negative? Well, it's going to be definitely a negative, and you've got 3 to 1 divided by 3 times 2 times 1, so it's just going to be a 1, and you get an x cubed. Now, this is just going to keep going on and on and on, because if you were to find the next one, well, you can probably predict what the next one is going to be, and I'll do it in a different colour because it's not really part of the question. The next one would be plus x to the 4, and then it would be minus x to the 5 plus x to the 6, okay? And you're probably thinking, how on earth is this the same as this? And it isn't quite the same as it, and we'll talk a bit more about that in just a second. But at the moment, we're just practicing using the formula, so you're going to have to trust me for a bit. Okay, so this one, again, it wants the first 4 terms of this thing that I've got here. So, to begin with, you're going to write it out in index form. So it's going to be 1 minus 3x to the half. Now, as long as you've got the 1 there, it's all absolutely fine. We don't have an x, but that is completely fine. It just means any time that we have an x in any of these places, we're just going to replace it with a minus 3x. So this is the thing that's like our kind of x, and this thing here is the n part that we have. So I'm just going to dive straight in. I can see that it goes to begin with. It's always got that 1 at the beginning. So it's 1 plus n, which is a half, and x, which is minus 3x. Now my next bit is going to be n multiplied by, if my pen decides it's going to behave, multiplied by n. Now, a half minus 1 is minus a half. That's n minus 1 over 2 factorial. Now, 2 factorial is just 2, so you don't really need to worry about that much. And then my next one is going to be, oh, don't forget to square it for this one here. Silly me. And then we've got n minus 1. And then minus a half minus 1 is minus 3 over 2. And that's going to be divided by 3 factorial. And I just know that 3 factorial is 6 because it's 3 times 2 times 1. And then instead of doing x cubed, we're going to do our minus 3x all cubed. So you've just got to be careful now about how you work this part out, okay? So I have 1, and then I've got a half multiplied by minus 3. Well, it's clearly going to be a minus. It's going to be minus 3 over 2x. Now here, just think first of all if it's going to be positive or negative. You're squaring a negative number, so that's positive, and then you've got a positive, it's going to be negative. And then I wouldn't really want to type all of this into my calculator. I would just think, okay, I've dealt with the negative, so I'm just going to do a half times 9 divided by 2. So that's a half times 9 divided by 2. And you get 9 over 8x squared. And do you see how I didn't need to worry about the negative? Because I already thought sensibly to myself, what is that going to be to begin with? So let's think if this one's going to be positive or negative. Okay, so it's positive, negative, positive. So this bit here is positive, but you've got a negative number being cubed, so it's going to be a negative. So this is 6, and you can do 3 cubed here. So it's going to be half times 1.5 times 3 cubed divided by 6. And you don't have to worry about the negatives because we've already decided it's going to be negative. So I'm going to do a half times 1.5 times 3 cubed divided by 6. Put that all in my calculator and I get 27 over 16x cubed. And of course, this keeps going, but the pattern is a little bit harder to spot about what this one might be. Okay? So these are not always going to be valid, okay? Do you remember I said here, this doesn't really look like this is going to be the same thing as this, because I can already think of some values if I put in for x that's not going to make this the same as this. So we're going to think about why, when these things are actually valid, because they're not always going to be valid, these binomial expansions. They don't always work. So our expansion might be an infinite number of terms, and if so, the result must converge. Now you know what converge means from sequences and series. It means that it goes to a particular value. Think to yourself, what is the opposite of the word converge? The opposite of the word converge is to diverge, and for diverging means it does not go towards a particular value, okay? For it to be valid, it needs to converge to a particular result. So on the previous page, we came up with that 1 over 1 plus x is 1 minus x plus x squared minus x cubed. So we need to think about what would happen to this expansion if x was greater than 1. Well, I don't know. Let's just think of an example. Let's say that we put in that x was equal to 2. We would have on this side, we would have that 1 over 1 plus x is just going to be 1 over 3. So we can clearly substitute that in. But if I substituted 2 in here, I would get 1 minus 2 plus 2 squared minus 2 cubed plus 2 to the power of 4. Now what is going to happen to this sequence? Is it going to converge to a particular value? So that's going to be 1 minus 2 plus 4 minus 8 plus 16. The next one is going to be minus 32 plus 64. These are getting bigger and bigger and bigger each time. So this does not converge, it diverges. And it certainly doesn't look like it's going to be anything close to 1/3, okay? So let's try something different. Let's try now if x is a small number between 0 and 1. Let's say that x was equal to, I don't know, let's just go with 0.5. So we would have 1 over 1 plus x, that would be 1 over 1 plus 5. I'm being lazy, as you can see. 1 over 1 plus 5 is 2 over 3 when you put that in. So we're hoping we're going to get something that's a bit like 2 over 3. So if I do 1 minus 0.5 plus 0.5 squared minus 0.5 cubed plus 0.5 to the power of 4 minus 0.5 to the power of 5, will this converge to something? Well, if you think about your geometric series, it will converge because the common ratio as you go across is less than 1. It's actually between 0 and 1 in our particular case. And let's just actually work out what this bit is here. If I was to type that in, so if I do 1 minus 0.5 plus 0.5 squared minus 0.5 cubed plus 0.5 to the power of 4, and I will do minus 0.5 to the power of 5. And you get 21 over 32, which is roughly equal to 0.66 to 2 decimal places. Yeah, it's kind of close to 2/3. So why does this happen? Well, this happens because when you're squaring these numbers that you've got here, the 0.5, and when you're doing them to higher powers, they get smaller and smaller and smaller, so it converges. But here, when you were squaring these x values, they were getting bigger and bigger. Like you had 64, that's huge. Whereas 0.5 to the power of 5, that's very, very small. And you can see a really similar pattern here. If you had that x was between 0 and minus 1, let's just say that x was equal to minus 0.5. I'm not going to do this whole kind of thing over here, but you can actually see you're going to get the same kind of thing when you substitute 0.5 into these things. The higher powers, let's see if I can write this on here with the pen not going as rubbish as it has done here. What we can see is the higher powers will get smaller and smaller. You can hear my laptop heavily trying to stay cool. The higher powers will get smaller and smaller, so it converges. And then you've got this weird one down here. If x is equal to 1, well, let's just actually substitute straight in. We can see if x was equal to 1, it's just going to be a half on that side. So we're hoping it would be a half. But if we substitute it in, you'd get 1 minus 1 plus 1 squared minus 1 cubed plus 1 to the power of 4. In other words, it's 1 minus 1 plus 1 minus 1 plus 1 minus 1. Like, what on earth is that going to do? Does that converge to something? No, it doesn't converge. So, looks like the only ones that actually converge are this one and this one. This didn't converge and this didn't converge. These ones actually give us good estimates. The one at the top and the bottom do not. So the requirement that we have on x, combining these two inequalities that we've got here, is that x needs to be greater than 1 and less than, sorry, greater than -1 and less than 1. Has to be in between these values. Any x value in between these values, when you do the high powers of them, they will get smaller and smaller, so it will converge. But the most common way that you will see this written is just that the magnitude of x is less than 1. Note how it cannot be equal to 1. If it's equal to 1, you get this weird thing happening here where it does not converge. So the modulus of x must be less than 1. So, expansions are allowed to be infinite. However, the result must converge. That's what we've just said there. So this time, we're going to think about what needs to be between -1 and 1 for the expansion to be valid. Well, it's not going to be x that needs to be between 1 and -1. In this particular case, because this is the thing that we were treating as our x, it is this thing that needs to be between 1 and -1. So really what we're saying is that -3x needs to be less than 1. And the modulus sign just means that's the same as 3x has got to be less than 1. And then you can divide both sides by 3. So in this particular case, x actually needs to be less than 1/3. And that's because these things that are being squared here, if x was more than 1/3, then you're going to square something and it's going to get bigger and bigger and bigger. So we need these things inside here to be less than 1. And so this is the kind of way we do this. Okay, so really quickly just going to think about when these things are valid. If it's this standard one, it's valid if the modulus of x is less than 1. In this one that we've got here, this is our x part. So it's going to be valid if 2x is less than 1. In other words, if x is less than a half, not or equal to, a half. So I've divided both sides by 2. Now this one I've just got -x, so it's just going to be the modulus of -x is less than 1. But when you take the modulus of something, you can ignore the negative, so it's just x has got to be less than 1. This one, it's going to be a quarter x that has got to be less than 1. And again, you can just multiply both sides by 4, so you get that the modulus of x has got to be less than 4. And this one that we've got here, we've got -2/3 x has got to be less than 1, where you can ignore the modulus sign, so you have 2/3 x is less than 1. And then you can multiply both sides by 3 and divide by 2, so that we get that x has got to be less than, multiplying by 3 and divided by 2. Okay, so these will only be valid, they will only converge if these things are true for when you substitute in. Okay, we're doing pretty well here, we're going to keep going. You can also combine expansions together, okay? You can do binomial expansions for things that look like this. Now, at first glance, this doesn't appear to be a binomial expansion, but it does say use the binomial expansion to show that this thing is here, this thing is true. And notice how they tell you the, what do we call that? The expansion is only valid if the size of x is less than 1, because you can see if you put in something that was bigger than 1, it's going to get bigger and bigger and bigger, and it won't converge. So the first job that we need to do here is take something that looks like it's one single thing, and we need to make it as two binomials being multiplied together. So the overall thing is a 1 plus x over 1 minus x to the half. Okay, we always want to put these things in index form. Now this is the same as 1 plus x to the half over 1 minus x to the half, because you know you can apply the powers to the top and the bottom. But this isn't a product, this is still a division. So if I was going to write this as a product, it's 1 plus x to the half multiplied by, well, 1 minus x to the minus a half. Okay. And then it says, how many terms do we need in each expansion? Well, look here. It's only going up to x squared, so we only need 3 terms per expansion. And what we're going to do is we will work out this expansion, and then we will multiply it by this expansion, and then we will ignore any terms higher than x squared. Okay, so I'm going to start off by doing this first one that we've got here. Let's do that in a colour. I'm being a bit lazy and not really using any colours. I don't like any of these colours, so I'm actually just going to not do that. Okay, we'll do our first one, which is our 1 plus x to the half. Now, I haven't got the formula up there. I hope you can remember it. So it is 1 plus n x plus n minus 1 over 2 factorial multiplied by x squared. And I can stop there. I'm just going to simplify that. So it's 1 plus a half x. Now I've got a half. First of all, it's obviously going to be negative, okay, because I've got a negative here. And so I've got a half times a half divided by 2. My calculator has got such low battery. Half times a half divided by 2, that is an eighth. So that's an eighth x squared. And then our next one is 1 minus x to the minus a half. So that's 1 plus, this is our n here. So let's not even do the plus. We're going to do 1 plus nx. So that's going to be a minus a half because that's our value of n. And then we're going to have n. Come on, laptop, don't die on me now. One plus n, which is minus a half. N minus 1, which is minus 3 over 2, over 2 factorial x squared. And we'll just do some simplifying. So that's 1 minus a half x. And you can tell it's going to be positive here because you've got a negative times a negative. And you've got 0.5. For some reason, I just prefer to do decimals when they're super easy like that. 0.5 times 1.5, all divided by 2. And we get 3/8 of x squared. Okay, so now we know that this thing, which of these two things being multiplied together, is... So we've got 1 plus x to the half, 1 minus x to the minus a half. We know that that is approximately equal to this thing multiplied by this thing. So that's 1 plus a half x minus an eighth x squared multiplied by 1 minus a half x plus 3/8 x squared. Now I said you can ignore any terms higher than x squared, and we can actually start doing that right away. So I'm not going to do a full expansion here. I'm just going to expand the things that will give me something that is either a constant, an x, or an x squared. If it gives me an x cubed, I'm not even going to write it down. You do not need to write it down. Okay, so I'm going to multiply everything in this second bracket by 1. So I've got 1 times 1. I've got 1 times minus a half x. I've got 1 times 3 over 8 x squared. Okay, easy. Now I'm going to do these multiplied by it. So I've got a half x times 1. That's just a half x. I've got a half x times minus a half x. So that's going to be minus a quarter x squared. And then I've got a half x times 3 over 8 x squared. That's going to give me a cubed, so I'm not even going to write it down. Now I'm going to just do this bit here. So I'm going to do my minus 1/8 x squared multiplied by 1. So it's minus 1/8 x squared multiplied by 1. And when I do this x squared multiplied by x, it's going to give me a cubed, so I can ignore that one. So I'm just going to actually finish doing this simplifying that I've got here. So I've just got the 1. Great, that's what they have here. I've then got minus a half x plus a half x, which is not what I want. What have I done wrong? Where's this gone wrong? I hope somebody can spot this before I've done it. Let's just check if the x squared bit is right. So the x squared bit, we've got 3/8 minus a quarter minus an eighth. 3/8 minus a quarter minus an eighth. And we get none of the x squareds. So I need to spot where I've gone wrong. Right. I think I can see it already. I did not notice this. So everywhere I've written x, I should have written minus x. I'm going to do this in a different colour so it's blatantly obvious to you that I've done this wrong. So there's my minus x. This bit here should be... You would have told me this way quicker if we were in class, I tell you that. This should be our minus x squared here. And then this one... That's it, actually. I don't need to do that one. What did I have written there? That was my... Okay, so let's figure out what's different. So we've got a negative times a negative. It should have been a positive. And then here you've got a negative squared times a negative times a negative. Yep, it is a positive. So that's going to stay the same. The only thing is that that should have been a 1/2 x. Now let's check the expansion again. So that should have been a plus 1/2 x. And then we've got here, this also should have been plus 1/4 that we have here. And then have we got anything else that I've done wrong? I think that's all good. So we've got the 1. We've then got 1/2 x plus 1/2 x is an x. And then I've got 3/8 x squared. So it's 3/8 plus 1/4 minus an 1/8. And I'm hoping this is a half, and it is. Good. So I get plus 1/2 x squared. Do not make my mistake of just going ahead. You've got to make sure you use whatever the thing is that we have there, okay? So we've done that first question, and that's combining those things together. I'm afraid I've got to keep going. There's a few more things I need to do on this. Do I want to do this one here? Yes, let me think. 1, 2, you can try that. Yeah, we're going to do this last question and then we're done on this video. So this is one of the new spec exam questions, okay? You might like to have a go at this one because it's similar to what we've just done on this page that we've got here about combining the expansions. But I think I want to talk to you about some of these things that we've got here, okay? So first of all, I'm going to do this bit nice and quick. I'm going to do binomial expansions to show that this thing is true that we've got. So we have 1 plus 4x over 1 minus x to the half. I wonder if we can do this a bit quicker, if we can just say that that's 1 plus 4x to the half, and then the denominator is 1 minus x to the minus a half. Now, I have actually already worked out this bit, so I'm not going to spend too long on doing the second bit, but I am going to do the 1 plus 4x to the half a bit more carefully than I did before. So that's going to be 1 plus n, and x is actually 4x, so that's what I didn't do on the last one, that's what I did in red wrong. And I'm now going to do plus n minus 1 over 2 factorial x squared. And remember, you can stop at the x squared bit, because this is only going up to x squared that we've got here. And I better work that out and come up with that a bit more neatly. So that's going to be 1 plus 2x, a half times 4 is 2. So I've got 4 squared. First of all, let's figure out this is going to be a negative, because there's just a negative times a positive times a positive. So I've got 0.5 times 0.5 times 4 squared divided by 2 factorial, and you get 2. So you get minus 2x squared. Now I'm going to be a bit cheeky. I'm going to use what we've done on the previous page. 1 minus x to the minus a half. If I scroll up here, 1 minus x to the minus a half is 1 plus a half x plus 3/8 x squared. Oh my god, am I going to remember that? 1 plus a half x plus 3/8 x squared. And so we want to find out what this thing is equal to. So we're going to actually just multiply these things together. So I've got my 1 plus 2x minus 2x squared is equal to, multiplied by 1 plus a half x plus 3/8 x squared. And remember, you can ignore anything with cubics. So first of all, I'm going to multiply everything in here by the 1. So I get 1 plus a half x plus 3/8 x squared. Now I'm going to multiply by the 2x, so I'm going to get plus 2x plus, and then that's the 2x, and then these multiplied together is just going to be plus x squared, and then I can ignore the next bit because it's going to give me a cubed, and then the only one that's going to give me a squared here is these ones. The rest are going to give me cubics and quartics. So these things they give me is just minus 2x squared. Simplifying all of this, I've got 1, and then I've got plus 3 over 2x, and then I've got 3/8 x squared, so it's 3/8 plus 1 minus 2, and that's minus 5/8 x squared. Let's check to see that is what I have got here. No, what have I done wrong? Oh, I haven't added together correctly. A half plus 2x is 5 over 2x. That's where it's great when they tell you to show what the answer is equal to. So we've got 5 over 2x minus 5 over 8x squared. Okay, a student substitutes x equals a half into both sides of the approximation shown in part A in an attempt to find an approximation to root 6. Give a reason why the student should not use x equals a half. Okay, well, maybe we should try and figure out when this thing is actually valid, okay? This one here is only valid if the 4x is less than 1. In other words, if x is less than a quarter. This one here is only valid if this thing, which is minus x, I'm just going to write it as x, is less than 1. So because our student has used a half, what is the issue? The student should not use x equals a half because, which one's the problem? This one is the problem because the expansion is only valid for x being less than a quarter, and a half is obviously greater than a quarter, okay? Now, if you think about why it's this one that dominates, it's because this one is smaller, okay? So because this is a much smaller inequality, if you think between 1 and minus 1 is like this, but between a quarter and minus a quarter is like this, and they both need to be satisfied for it to be true, okay? This one now says, for part C, substitute x equals 1 over 11 into this to find an approximation for root 6. Well, we better investigate what the left-hand side is actually equal to, first of all, okay? So they have said that x is equal to 1/11. And I want to see, what is the left-hand side even talking about? Is it going to give me root 6? So the left-hand side would be 1 plus 4/11 over 1 minus 1 over 11. So that is going to be the square root of, what on earth is that going to be? So we've got 1 plus 4 over 11, so that's 15 over 11, all over 1 minus 1 over 11. What am I doing? Why am I doing this on my calculator? Which is 10 over 11. And 15 over 11 divided by 10 over 11, well, you can multiply the top and bottom by 11, so you get root 15 over 10, which is the same as simplifying the fraction, you get root of 3 over 2. And if I do that root on my calculator, you get that this is root 6 over 2. So the left-hand side gives you root 6 over 2. Let's work out now what the right-hand side is. So the right-hand side would be 1 plus 5 over 2x. Well, x is 1 over 11. And it's going to be minus 5 over 8, 1 over 11 squared. I'm just going to put this in my calculator. In fact, I'm going to store 1 over 11 as my answer. So that's 1 plus 5 over 2 answer minus 5 over 8 multiplied by my answer squared, just to save me a bit of time. And this comes out as 1183 over 968. And let's just do this. Oh, it wanted it as a fraction in its simplest form, but what I'm going to do is just see what this is as a decimal as well. So we've got 1.222, okay? Now that's not quite finished, because we've now got that root 6 over 2 is equal to 1183 over 968, and they want you to find an approximation to root 6. So that was our left-hand side, this was our right-hand side, so root 6 is going to be equal to this thing multiplied by 2. So let's multiply that by 2, and we get 1183 over 484, okay? I'm now going to just give you the left-hand side and the right-hand side as decimals to show you why this works and what's good about this. So the right-hand side is, as a decimal, 2.444, and root 6 is 2.449. So they're pretty close to each other. And if you wanted to make this more accurate, something you could do is, instead of just doing it as 1x squared, you could also add in an x cubed, and it would become more useful to do that, okay? So that's a kind of new style exam question that we've got there. I like this bit at the end where you don't just substitute in 1 over 11, you have to substitute it in both sides and see, does it give you root 6 or does it give you something similar to root 6? So let's see that this worked. Yep, we came up with this that they had here because that was a show that. Expression is valid for this, so you should not use this because it's bigger than that. And the answer that we got in the end is 1183 over 484, okay? So they kind of came up. Is that what we got, 1183 over 484? 1183 over 484, good. So we came up with the right answer there. Okay, so this is your turn to try a question. Just a bit of binomial expansion, and then you can pause it and have a go. and then we are basically nearly done, okay? So for this binomial expansion, you can have a go yourself, but I'm going to start this one now. So I'm going to go up to the x cubed term, and I'm going to state the values of x, which is valid. So it's clearly a 1 plus 4x to the minus 2. So sometimes I like to write this down that my n is minus 2 and my x bit that I'm using, maybe I should have done this before, is my 4x. So it is going to be 1 plus n x plus n minus 1 over 2 factorial multiplied by x squared plus n minus 1, n minus 2 over 3 factorial multiplied by x cubed. I'm going to stop x cubed. So you get 1 minus 8x. You can see that this one is going to be a positive. The 2's are going to cancel. And I've got 4 squared, which is 16, times that by 3, which is 48. So it's 48x squared. Equally, you could just put this in your calculator, but I know it's positive. The 2's are going to cancel. 3 times 4 squared is 48. Okay, so this one is going to be, overall, think to yourself, negative or positive. Well, that's positive, negative, positive, negative. And 3 factorial is 3 times 2. So actually, that's going to cancel with that and that. So I've just got left over a 4 and a 4 cubed. So that's 4 to the power of 4, which is just 256. So I get 256 x cubed. Now remember, this is valid when this thing here is less than 1. So it is valid for the modulus of 4x being less than 1. In other words, the modulus of x, oh, I knew it was going to do that. The modulus of x being less than a quarter. Okay, you could substitute in some values to the left-hand side, the left-hand side here and the right-hand side here, and if you get them really close to each other, then it should work out. Last bit, how accurate are these approximations? So in this particular one that we've got here, if x was equal to 0.1, how accurate would the approximation be for the value of 1 over 1 plus x? Well, actually, because x is very small, the approximation will be good. Can't deal with this pen. The approximation will be good. And what this means is smaller values of x provide better approximations. I'm really quickly just going to substitute in here, just those three, and in here, 0.01. So I'm going to do 1 over 1 plus 0.01, which is 0.99009900, and that just keeps going. And if I substitute 0.01 on the right hand side, so I'm just going to store it as an answer, 1 minus answer plus answer squared, we get 0.9901. And actually, that's correct to 4 decimal places. So it's a good approximation. So common errors that people might make here. What are the errors that people might make a mistake of? So sign errors, they might do things like this. They might forget that when you're doing a negative squared, you get a positive. Not putting brackets around the minus 3x, so that when you square it, you might write minus 3x squared instead of minus 3x all squared to remind yourself it's squaring this and it's squaring this. And sometimes people make a mistake of dividing by 3 instead of 3 factorial, which is just 3 times 2 times 1, which is just 6. Those are the most common mistakes that people make. And I would say the other mistake, seeing as I made it myself, was, which question was it in? Here, that you need to make sure that you're substituting in whatever that whole expression is for the x kind of value that you've got there. So you can try exercise 4A. Lots and lots been done in that one, so you may need to go back to the video and have a go at some of these later on. If you want, there is a bonus question here for you. I've got an answer down in the corner. I'm not going to go through it myself though, but you can have a look and see how this is done. Okay, see you guys later.